welcome everyone to the HiveMQ webinar MQTT 5, Why You Need It and Potential Pitfalls. We are happy that you are joining our webinar. I am Verena, and next to me is HiveMQ CTO, co-founder, and today's speaker, Dominic. Hi, Dominic. Nice to have you here. We will start the webinar shortly, but before we begin, I have some hints for you. So you can ask questions during the webinar by clicking on the Q&A tab. Questions will be answered either during the webinar by Ian Scarrett or afterwards during the Q&A session by Dominic. Probably there won't be enough time to answer all of your questions. Therefore, all unanswered questions will be answered on the HiveMQ community forum. And the link to the community forum will be shared in the chat later. Additionally, we also start a quick poll during the Q&A session and would be pleased if you could give feedback on the webinar. And for your information, we are also recording the webinar and will upload the whole video on YouTube if you want to watch it again. And I think now it is time to start, so I will hand over to you, Dominic.
Thank you, Verena. So also welcome everybody from my side. My name is Dominic Obermeier. I am the CTO here at HiveMQ, and I myself have a background in distributed and large-scale systems architecture. I developed MQTT 5 along with other members at the OASIS Technical Committee. I'm an author and a conference speaker, and I also organize German and international IoT conferences. If you like what you hear today, you can also follow me on Twitter. My Twitter handle is on the left above my picture. So if you're interested in Internet of Things content, in technical content also about MQTT, this is a good place to start. So before we are talking about MQTT 5, the next generation of the IoT protocol, I'd like to give a quick refresher about MQTT, what are the use cases and what it's about, and then dive into the new features, the pitfalls, what we've learned so far about MQTT 5 and live deployments. And we will also look at the ecosystem, what tools are out there, what client libraries can you use, what brokers can you use, and how does MQTT 5 and MQTT 3 work together in a production environment. Again, if you have any questions, you can ask the questions anytime during the webinar, and we will try to answer, and my team will try to answer the questions directly. And at the end, we will also have a slot where we can discuss the questions in detail. Okay, let's start with a quick MQTT refresher. So MQTT is at its core an Internet of Things messaging protocol. It has some very unique and distinct features like different quality of service levels, so-called retained messages, persistent offline sessions, and it's binary with minimal overhead. In general, MQTT is used to move data from devices over the internet to backend application and from the backend back to the devices. And it really depends, of course, also if you are in an industrial IoT use case, probably you don't have a cloud component, but you can also use MQTT. But in a nutshell, it's really designed for a very lightweight data movement between devices, backends, and applications. So typical use cases where MQTT is used. So from a technical perspective, it's very often when push communication is required. So this means data needs to be moved in a very quick and efficient way to, let's say, mobile devices, Internet of Things devices, and applications. And MQTT really provides a reliable communication layer over unreliable networks. Unreliable networks are usually Wi-Fi, mobile networks, but also even some wired networks can be unreliable at times. And MQTT provides a layer for the application developer where you can assume the unreliable network is reliable. So this makes it a very good protocol choice for moving devices like cars and so on. It's also built for constrained devices. And with constrained devices, I mean very low powered, very low CPU, and very low memory devices, which you also happen to see in industrial shop floors, but also in cars or in consumer gadgets. So usually you don't have a lot of computing power you can use for your communication, and this is where MQTT really shines, as well as low bandwidth and high latency environments. And MQTT is very often used to retrofit your existing enterprise backends to also allow mobile communication to your backends. And MQTT is very often used as a communication layer there. So the use cases you see here usually is in the connected car space, in the Industry 4.0 or industrial IoT space, logistics, transportation, general IoT messaging middleware, and telecommunications. Here at HiveMQ, we have a lot of customers in different industries. So we have seen from smart agriculture to connected car to logistics, transportation, to consumer gadgets, a lot of different use cases, and MQTT basically is used everywhere where the label IoT is used. So how does MQTT work? This is also in a nutshell and a very high level overview. So at its core, MQTT provides a decoupled communication between devices. And what you see here in the picture is a MQTT broker, the heart of the communication, in the middle of the picture. And the MQTT broker is responsible for distributing data across all devices. And the cool thing is, if you have like a temperature sensor on the left, which publishes data, which sends data to the broker can distribute this piece of data to any device, to any application which is interested in this data. And the temperature sensor never needs to know what consumers may be there. And the consumers also don't necessarily require to know that this is a temperature sensor. It's really about the data. And this is a classic publish subscribe model. And at its core, MQTT is really designed for this, but also at scale. So we will talk about this in a minute, but when we talk about MQTT, very often we're talking about a lot of message throughput, which means a lot of data is sent simultaneously, a lot of data is consumed, but also very often we're talking about a lot of devices. So here at HiveMQ, we have experienced up to 10 million concurrent connections in production environments. So we are really talking about scale here. Okay, so you probably might think, yeah, MQTT, this is the cool kid on the block nowadays. So it must be a pretty recent technology. But this is not really true. MQTT, while it's a very recent technology and which recently is used a lot in the industry, the technology itself is not that new and basically has a lot of years where it matured in the past. So MQTT was invented in 1999. So it's actually a granddaddy when it comes to Internet of Things protocols, before it was even called Internet of Things, and it was invented for oil pipeline monitoring. And it turns out that the problems you solve for oil pipeline monitoring in 1999 are the exact same challenges you have for nowadays IoT communication. So there was a bit of time until 2010 where MQTT 3.1 was opened as a royalty-free protocol. And this was opened by IBM. And the idea was to have not only IBM use MQTT and other companies, but really have an industry standard where, yeah, basically everybody can contribute to and gain a user base. Because MQTT, again, the challenges you see in the Internet of Things communications today are the exact same you had for SCADA system communications over the internet in 1999. 2012, Mosquito 1.0 was released. This was the first popular MQTT broker, which is also open source. And then in 2013, HiveMQ, the first public release was 1.3, was released 2013, and was one of the first also commercial products which is used in a lot of mission critical deployments today. Also in 2013, the MQTT technical committee at OASIS was formed, and a lot of industry players came together and standardized on MQTT, which was released in 2014. This is the version. If you're an MQTT user today, you probably are a user of MQTT 3.1.1, which is the most recent version. Before MQTT5, the most recent version. And it's also an ISO standard. And 2018, beginning of 2019, MQTT5 was officially released. And also in 2018, HiveMQ4, which is the newest generation of our product, got MQTT5 support. So we support MQTT5 since quite a time. Also, MQTT is really popular today. You see here a chart on Google Trends, on Google search. So people are really interested in MQTT, and it's the default protocol for any IoT communication nowadays. So I talked about the MQTT technical committee at OASIS, and you might wonder what players are standardizing on MQTT. And there are a lot players here, but basically you have giants like IBM, Cisco, Microsoft, Software AG, and other players. But as well, we as HiveMQ, we are one of the smaller companies who are also standardizing on MQTT, which also allows us to build implementations for new versions pretty fast, because one of our things we strive for is having, as soon as there are some developments on a TC, having a software which is production ready as soon as possible. Okay, but now let's talk about MQTT5, why you need it, what it can do, how it can help you, and what software is out there. I already said this, MQTT5 is a successor of MQTT 3.1.1. It's officially released. It was released officially in March 2019, but the first public version was available in January 2018. And fortunately, a lot of people and developers came together and started implementing the standard in 2018. And HiveMQ officially released the MQTT5 support basically before it was released officially, before the MQTT5 was released officially in March 2019. So it's pretty recent, but there are a lot of users today of the new standard. So the bad news here is MQTT5 is non-backward compatible. The good news is I will show you a way how you can use MQTT 3 and 5 together, and then it's basically is compatible with older versions. So there is a way, but it's not by default. But I will show you in this presentation today. And we will have now we will dive into a lot of the new features after we look at the goals. So one might think, yeah, you know what, MQTT 3 has some good traction. Why do we need a new version? And the answer is there are a lot of reasons for a new version. Basically, the user base over the years collected a lot of feedback, and at the technical committee, the feedback was heard, and we created a new standard. And basically, these are really the topics we focused on. It's about enhancements for scalability in large-scale systems. So with the new standard, you can even scale higher. So with HiveMQ, you can scale to more than 10 million of devices, which is pretty large scale. It also has improved error reporting built in the new protocol version, which was one of the features a lot of developers requested. A lot of formal patterns. And one of the things which was really discussed heavily was extensibility mechanisms. I will also show you how you can use this in your projects, and this is really cool, and we see a lot of traction and adoption of these new mechanisms. And of course, performance improvements and support for small clients. So MQTT5 really makes sure that the constrained devices still don't require a lot of memory and computing power to use all the new features. Okay, let's dive into it. What are the new features? Basically, there are more than 23 new features MQTT5 has, some smaller and some larger features. We focus now on the features we believe are game changers. And if you are not using these features right now, you are probably very interested in these. There are some smaller features we will cover in the end, which are more like for edge cases. But here are really the big features. And some of them really are game changers. And as soon as we saw customers adopting these new patterns and features, it really made the life a lot easier. Let me start with session and message expiry. So before talking about this feature, session and message expiry is one of the things MQTT3 had no support. This basically meant it was broker dependent, vendor dependent, how long messages and MQTT client sessions were available and when they were deleted. And there were even some products out there which never deleted anything. So you basically built in your denial of service attack if you did not configure anything. So of course, commercial brokers, also like HiveMQ, but also open source brokers like Mosquito, they made sure that they clean up things and there is a session and message expiry mechanism, but completely broker dependent. And now the goal was to find broker and vendor independent mechanism for deleting sessions and messages which are not required anymore. So this is actually pretty easy. The MQTT connect message, which is the first message a device sends when connecting to an MQTT broker, can now have a so-called session expiry header. And imagine like the following: if you have an industrial machine, or better, even a car, and the car can now say, hey, please broker, I have an MQTT session for, let's say, 5 days. And if I don't come back in 5 days, please delete everything. This is important to make sure that there is no stale data on the broker side, but also probably a car won't be interested in data which is more than 5 days old, or even a week or a month. So basically each device can now tell the broker what the individual session expiry interval should be in seconds. So you might have a machine which should not expire at all. So even if it will come back after a year, it gets all data, but you might have some short-lived clients and they can just tell the broker, hey, you know what, please delete my session after 1 minute if I don't come back. So this, now you as a programmer, now the architects also have everything they need to build this into the client logic and without any back-end configuration. Also, the same is true for publishers. Imagine the following use case. Let's say you build a car and you get GPS updates if there is an accident on the street, for instance. And you send out this message to devices. If you have a car which is in the garage for 2 weeks, it probably is not interested in 2 weeks old accident messages on the street because they probably are not relevant anymore. So what you can do here is when you publish a message, you can tell the broker, this message is valid for, let's say, 1 day. And after this day, please delete the message for me and don't deliver it anymore because it's not useful anymore. So this is a pretty cool mechanism to have an expiry on the message itself. And you can do this on each individual publish. So you can even decide topics which have short-lived session expiries and message expiries and long-lived expiries. So this is now completely individual. Okay, let's also cover one of the most frequently asked features, the so-called user properties. And if you're familiar with HTTP, you know what this is. These are basically custom headers. So in the past with MQTT3, you basically had one byte blob where you can put in all your data. And now MQTT allows you to put in any data in the packet without being in the payload. So this means you have you have, similar to HTTP headers, you can parse, and you can use for a custom logic, which even allows you to build custom protocols on top. And the cool thing is you can add an unlimited number of user properties to an MQTT message, and basically up to 250 megabytes. I will talk about pitfalls soon. As you can imagine, there are some pitfalls there, and I will talk about the experience we had in production environments about user properties, what to do and what not to do. So basically, if you need user properties, it's super awesome, but you can also design a very unelegant solution, which might bring you troubles. So stay tuned for this. I will talk about this soon. Share subscriptions. This is one of the features which is, from my point of view, mandatory for almost all production deployments I've seen in the past. And this is something some brokers supported. So HiveMQ supported this. Some open source brokers like Mosquito did not support this in the past. This is now standardized, and this is a feature. I bet you will use this if you have some kind of backend communication, because there are so many advantages to this, and I will show you. So basically, what a shared subscription is, it's like, so imagine the following use case. You have a lot. Let's also do a car example. So let's say you have hundreds of thousands of cars, and each of these cars send a GPS update where the car is located. And then you have a backend application which wants to consume all these hundreds of thousands messages and do some predictions and machine learning, how the streets are doing, if there's any congestion on the street or whatever. So probably you don't have a backend service which can consume hundreds of thousands messages per second. The broker might deliver this, but you won't be able to consume these messages. And what you actually want to do here is having a microservice architecture and scale out your backend application. So you can basically consume, so you make sure that each message is consumed for the same so-called shared subscription, but the broker can load balance. So if you say, okay, you have a shared, these services form a shared subscription, they have one logical subscription, and the broker makes sure to deliver for MQT client 1 a message, and then for MQT client 2 a message. So you can distribute the message stream across multiple consumers. And this is super powerful because you can scale up and down on the fly without any configuration. And this is super important for any dynamic environments, which you often have on Kubernetes or similar technologies, where services can come and go and the data streams can be consumed in different ways. And basically you can have different, for the same topics, you can have different shared subscribers, which can consume from the same stream. So basically you have full flexibility here. So we have also blog posts on this. So if you're interested in this, how to do this, but basically it's super easy. You just, as an MQTT client, the programmer would just subscribe the client to a so-called share topic, which is $share / some ID, and then the actual topic you want to subscribe to. And this is the shorthand for indicating the broker you want to have a share subscription. And then you can dynamically scale out, scale down how you need this and still have all MQTT guarantees you get. So this is very, very powerful. And this is also very often used for microservices and sometimes as an alternative to Kafka, as a very lightweight alternative to using Kafka. But be aware, this is an optional feature. This is not supported by every vendor, even MQTT 5. But most vendors will have this because you probably cannot do a production environment without share subscription. Okay, let's quickly jump to the next feature, so-called negative acknowledgements. Negative acknowledgements are also a much requested feature because the basic answer for the broker and the MQTT client for any error was disconnect. From a security perspective, this is the right answer in most of the cases. But from a developer perspective, this is sometimes pretty hard to debug. And MQTT 5 added a lot of error codes, and most MQTT packets can carry error codes. So if you're doing something wrong, like publishing or subscribing to a topic you're not allowed to, the broker will tell you. And then disconnect probably or not. This is something your administrator can configure. And you can also, especially for debug environments and for test environments, the broker is now able to also give a so-called error string to the client. So as a programmer, you even on your devices, you even get the reason, the human readable reason to your device, what happened, what went wrong. So you can log this and then you can debug accordingly. But of course, also here, this is super useful for test environments. Be careful when doing this in production, because you don't want to give attackers some indication, how to, let's say, brute force your MQTT broker. But again, super useful. This is a quick one, a payload format indicator. So each published message, so in the past, MQTT sees every message as a binary message. So MQTT doesn't care if there is text in there, if there's an image in there, or if there is some custom file format in there. Now you can tell the broker and the consumer of a message what kind of message this is. So number one, with the payload format indicator, you can tell, is this a binary message or is this a text message? So this makes it easier for parsing. But you also have a content type, which is, if you're familiar with HTTP, there are so-called MIME types, which indicates if you have, let's say, a text document, if you have a PDF, if you have your custom protocol you build for your application. And MQTT can now also indicate how to interpret the content, which is in the message. So this is very useful. And you can, of course, also build your own MIME types in there. So if you have a custom application protocol built on top of MQTT, you can just indicate, hey, this is my custom protocol. And then every consumer can figure out, do I understand the format or not? And of course, then make sure to parse or ignore the message. So this is also very important from a security perspective, that you don't parse messages you cannot interpret. Okay, and this now is a feature which some people wonder, why do I need this? People who are familiar with the publish subscribe architecture realize that request response is a completely different pattern, because request response would be basic HTTP. This means you have a client, you have a server, and the client gets the server and then gets an answer. This is how HTTP works. MQTT works with a publish subscribe architecture, which means a client subscribes to messages and the broker sends messages as soon as it's there. So it's completely reactive and event driven, while a request response pattern is not. But there are some use cases where you probably want to use a request response pattern on top of MQTT, which is possible. And this was seen so many times in the last few years by people doing this, that the TC decided to standardize this pattern so everybody can look at the best practices. But let me walk you through why you would need this. Imagine the following use case. You have an application which consumes messages, writes messages to a database, and as soon as the message is written to a database, an answer should be published back to the producing client that the message was persisted accordingly to the database or whatever. So basically what you see here in the picture is the following. In this MQTT client publishes a message to the broker forwards the message to an application. The application then takes care, writes to a database. And as soon as this is successful, it wants to notify the MQTT client. So it sends back a message to another topic, which the broker distributes to the client. So this would not really be a transaction, but this would be like a very asynchronous, lightweight way of looking at transactions, quote unquote. So you can make sure in an event-driven way to notify all your clients that you took care in your backend about data. So this is a pattern we've seen a lot, and people are doing this a lot. And now MQTT standardized on this. So sometimes this is referred to business acknowledgements, business X. And this is a pattern you can use, of course, with MQTT 3. But this was convention. So there was no way in the protocol to tell the consumer of a message where it should produce the answer to which topic. So this was really just convention. And I've seen at large customers, large document and Excel sheets, how to correlate these things. And now you can use in the protocol and also make sure that this will happen. So there's a so-called request response information header and a correlation data header. You can use this, and your consumer of a message can then figure out and read from the message it received where it should put the answer to which topic. So it can make sure that the producer of a message also gets the answer. So this is very powerful. It's a very small feature, but if you have this, this can really help you go away from large Excel sheets and conventions and really bake into your application how it should respond and then also you can debug, of course. Okay, another one. This is also a very popular one. Topic aliases. So sometimes there are use cases where you don't want to send a lot of data. So you want to send a few bytes of data, but then you need this large MQTT topic string for the broker to indicate where it should route the message to. So we have seen use cases where people send 10-byte messages of actual payload, but they have more than 100-byte topics. So this is a lot of waste of traffic and on computing power, basically. And MQTT 5 solves this issue and allows a producer of a message to say, okay, dear broker, when I will send to this topic a message again, I will just use number 1 or 2 or 3. And the broker is then required to keep track for this client and see, oh, message 2 goes to topic number 1 and not to a 100-byte topic string. And because the broker then creates a map basically of topic aliases. So you really send a few bytes over the wire instead of the actual topic stream all the time. So if you have a use case where bandwidth is key, this really saves you money at the end of the day. And this is a very popular feature. And basically, if you're using a proper MQTT client library, this will be under the hood. And of course, if you want to program this, most client libraries also support this. So basically, you can do this from client to server, but also from server to client. So if the server is smart enough and sees that the same client consumes the same topics all the time, then it can also use the topic aliases. So the client can also profit from lower bandwidth. Okay, this is an optional feature and it's not supported by all vendors, unfortunately, but it's a cool feature. Okay, one of the last big features is flow control. This is also under the hood, so you probably won't notice this that much. But if you're running in large scale systems right now, you probably have seen cases where clients could not cope with the amount of messages the broker sent. So let's do an example. The example is also, let's say there's a car in a garage for 1 week. And then it goes online again, it will probably have thousands of messages. And what is not a good strategy is that, let's say the broker would send all messages at once to the client, because if it's constrained, it will probably break the client. And vice versa. Also, if you have a very heavy producing client, probably you want to restrict clients also that they don't produce a lot of messages. Because you really want to make sure that nobody's breaking your deployment. And flow control allows you pretty easily to say, okay, each client is only allowed to have, let's say, 10 messages flowing in and out at the same time. And the server or the client, they need to wait until producing a new message until the old message is acknowledged. So this is really a good way of making sure that you don't have single clients which produce too fast or can cope with the amount of messages sent by the server. And some people know of the in-flight window concept in MQTT3, and flow control basically replaces this and is a much better, more robust way to do this. So now let's also talk about small improvements and then about pitfalls. There are also things like passwords are now allowed without usernames. Servers can now send disconnect packages with additional information. In the past, only clients could send a disconnect package with indication what went wrong, and now the server is also allowed to do this. The server can now tell the client, or the client can tell the server what the maximum message size it can handle is. There is stream and session state. There are a lot of options when subscribing, which makes the life easier for a lot of use cases. So we won't go into detail here, but there are blog posts upcoming on our blog which describe this in detail, because this is, again, are small features, but if you need it, you are really happy to have this. And you can also have so-called server keep alive, where the broker can tell you as a client what keep alive it supports and can even override what the client suggested, what a good keep alive is, and so on. So really, really good stuff here. But again, this is probably something, if you need this, you can read this up in our blog. So what are the pitfalls? Because of course, it's a shiny new technology, but what is the experience? And we have a lot of good experience with pitfalls, especially what went wrong when deploying MQTT5 and how to fix this. And so there are some mistakes, so please don't do them. So they're pretty easy to avoid and sometimes hard to fix. So please make sure that you take care here. Number one, optional features. I think I've seen MQTT5 has some optional features. And the problem is even a lot of MQTT3 features, which are now required for any MQTT implementation, are sometimes optional, like retained messages, like wildcards, and so on. So I have a list prepared later on so you can see this. So if someone has MQTT5 support, unfortunately, you cannot rely that the whole specification is there. And sometimes even features like shared subscriptions are not there, which is for some customers, I know, the reason to upgrade, or for some users. And so talk to your vendor what it supports. This is very important because MQTT5 is not MQTT5 for different vendors, unfortunately. There are some brokers which support 100% of the specification, namely HiveMQ and Mosquito. There might be other brokers out there, so please talk to your vendor if they support the features, and if not, what alternative you have. Because otherwise you cannot switch your implementation on the back end. So in order to avoid a vendor login, make sure that you get a list from your vendor what it does not support. And these are features you might be surprised, which are default for each MQTT3 implementation, like quality of service levels, wildcards, subscription identifiers, share subscriptions, maximum message size, server keep alive, and again, retained messages, which is really a core feature of the protocol, is optional with MQTT5. So be aware that not everybody will support this, unfortunately. Okay, compatibility. So not everybody has the luxury to start in a greenfield project. So sometimes you have devices, or most of the cases actually, you have devices out there which you need to support. And very often you have an older generation of devices out there and the newer generations would like to support MQTT5. The thing is, some broker vendors invested some time and made compatibility layers. So we also did this, and basically you can use MQTT3 and 5 at the same time without anything to take care, because the broker takes care about the mapping and the compatibility between the protocols. So we do this for our customers. If you're using another broker, make sure to also talk to your broker vendor what the migration path is and how to make sure that this is very seamless. So with HiveMQ4, again, we have use cases where MQTT3 devices are talking seamlessly to MQTT5 devices, and you can update them as needed, or you don't even need to update them at all. Number one, client ecosystem. We will also see this in a few minutes, where I have prepared some lists of who supports MQTT5 and who does not support MQTT5. So with the MQTT3, there is a vast amount of clients available on GitHub and also probably from your vendor. But MQTT5 clients are still in early days for some languages, and for some languages, there isn't even a production-ready library out there, unfortunately. But there are production-ready clients available, of course. And this is something we will see in the next slides. And the last thing here is also when we talk about security options. So security is a tough topic because security is really something you need to get right. Fortunately, you can use any security mechanism you can imagine with MQTT. MQTT5 introduced new headers for indicating what authentication method you want to use in case you have different devices which require different authentication methods. You can carry authentication data in a special header field. And there's also a new packet introduced, which allows to create challenge response protocols over MQTT, like Kerberos, for instance. The thing here is this makes things more complicated on a greenfield project. So also talk to your vendor what is recommended. There are best practices. We have a so-called enterprise security extension, which is opinionated and gives people who just want to get started with security and just want, let's say, OAuth authentication, who just want database authentication or whatever, to give them an opinionated best practice, which they can use, but also the flexibility to use any custom authentication authorization mechanism out there. So please make sure also here what is required for your use case and also talk to your vendor what it supports. There are different ways to do this, which is good for flexibility, but if you're starting, there are best practices, and talk to your vendor what the best practices are. So this is also super important. And now the very last thing, and I already mentioned this, don't overuse user properties. This is something which HTTP got wrong over the years. If you look, just open your browser and look what HTTP headers are sent. This is amazing. Don't do this with MQTT. It's supposed to be a lightweight protocol. Carry metadata. This is important, especially if you want to use the data in, let's say, interceptors in your extension system of your broker. Then user properties are very, very nice. And we've seen customers implementing custom protocols on top of MQTT easily in days and without a lot of business logic they needed to create because of user properties. So super nice. But if you see yourself in a situation where you don't carry any payload anymore, but a lot of user properties in your packets, then this is a huge anti-pattern. So as a rule of thumb, the user property should not be a lot more than the actual payload you're creating, because then we're talking about overhead. But again, this is something which is it depends on your application, on what you're doing. Create your user properties. Like there are some best practices for user properties, like if you encrypt your payload, then it might be a best practice or is a best practice to actually have some header which tells the application that this is encrypted, and probably also what way to decrypt without, of course, giving away any secrets it can use. So this would be very good, but don't use payload in headers just because you can use this. So be aware here. Okay, so should we upgrade yet to MQTT5? Let's look at the ecosystem. The broker compatibility. Mosquito has support for MQTT5. If you're a Mosquito user, then the good news is you can have all the features. It supports all optional features as far as we've seen and tested. And it's available since April 2019. So it's pretty recent, so it's not as battle tested, but to start, it's pretty nice, actually. And make sure to use version 1.6. All versions below 1.6 don't have MQTT5 support. If you're a HiveMQ user or in the Java ecosystem, There is a HiveMQ open source community edition that supports 100% of all MQTT 5 features, so you don't need the commercial version of HiveMQ. And this is available since 2018. So this is battle tested. Hybrid MQTT 3 and 5 deployments are possible. We support up to 10 million concurrent connections in a single cluster. And also the extension system allows to use all MQTT 5 functionality. In case you have some very special use case, you need to modify packets on the server. If you want to integrate systems, you get everything with MQTT 5. Everything is supported here. For the cloud platforms, unfortunately, none of the cloud platforms of AWS, Azure, and Google, they don't support MQTT 5 at the moment. I hope that they will support a lot of optional features, but as it is now, they don't even support the required features of MQTT 3, like retain messages, quality of service 2, or some of them. So it will be interesting to see what kind of features they will bring and how they will support MQTT 5. As of today, you cannot use MQTT 5 with them. So you need to stick with MQTT 3 if you're a user of them. I've seen users using another MQTT broker in front, like HiveMQ or Mosquito, and then route to these cloud platforms if you need MQTT 5 features. So some kind of proxy approach. If you're interested in this, you can also reach out afterwards so I can explain how this can be done. Client compatibility. So basically there is not a lot of competition when it comes to MQTT clients. So in the open source space, there's the Eclipse Paro project, which has production ready clients for for all languages you can imagine. And let's look what they support now. So the bad news is most of the libraries haven't had a release yet, which is production ready for MQTT 5. So at least their documentation suggests that this is not possible. There is fortunately a lot of activity on GitHub, but I'm not aware of any uses of this in production yet. So if you're using this in production with MQTT 5 yet, so please make sure to also write this in the questions. So I would be very interested in this. So, but there is a Rust and a C client out there for MQTT 5, which is very nice. There is not a Java client out there. For a Java client, an alternative which we developed together with BMW, with the car IT people from BMW, we created an Apache licensed open source MQTT client library designed for production use in mission critical environments. It's a reactive design. It's built for high scalability and most importantly, embeddability. So we're talking about sending up to tens of thousands of messages per second and maintaining really a very, very low overhead. So you usually don't notice the library at all when using this. So this is something which is used in production, which is used in mission critical systems, and it supports MQTT 5 from the core. It was designed for MQTT 5, but of course also supports MQTT 3. But all the APIs are designed for MQTT 5. So if you're starting a greenfield project with Java, take a look or wait until the Paro library. If you're a Paro user, I think there are some testers, they look for testers. So also testers. So I would be very curious to hear. I know a lot of production deployments with the HiveMQ MQT client. Okay, so should we upgrade yet? I would say yes. It depends. So if you are a HiveMQ user, yes, go with MQTT 5. If you're using another vendor, talk to your vendor. If you are using an MQTT library which doesn't have an MQTT 5 version yet, I think you're stuck at the moment. There are alternatives, but you need to decide. But for HiveMQ users, yes, you can have all the new features, all the goodies right now in production. And this is what customers are doing. And there's a seamless migration path. So there is no harm basically in creating new projects with MQTT 5. So yes, upgrading is a good idea. Okay, as a bonus, MQTT 5 and Kafka. Is this possible? Short version, yes. So HiveMQ integrates nicely and neatly with Kafka. And it has a bidirectional support for streaming messages from MQTT to Kafka and also consuming messages from Kafka and send it out to your devices. And what you can do, you can even parse if you want to send out messages from Kafka to your IoT devices over MQTT with the Kafka extension used by our customers. You can extract data from the Kafka messages and then use, for instance, MQTT5 headers, and you can send out everything. And this is really at extreme scale. And this is, of course, possible for HiveMQ 3 and 5. So if you're interested in this, talk to us. We're more than happy to show you the capabilities here. And so if you're more like the visual person, this basically means to have a broker cluster, a MQTT protocol layer on the left, where a lot of devices are talking to each other. And there's the native Kafka protocol HiveMQ integrates with, so it can read and write messages to Kafka, to different Kafka clusters even. And so that you can do this in a very fine-grained fashion. You can even have like topics, Kafka topics for MQTT3 messages, for 5 messages. So you have full flexibility here. Again, if this is interesting for you, talk to us. We're more than happy to show you this. As a summary, MQTT5 has new features you really shouldn't miss. And I did not tell you this in this webinar, but if you're in Industry 4.0 space, if you are doing industrial IoT, I think you really need MQTT5. If you're doing also connected cars, you probably already know about MQTT5, and this is because this is very, very important for a lot of functionality to have MQTT5. Be careful that your vendor supports everything, and really make sure to read the limitations, because otherwise you're excited about features you probably require but cannot use. And also MQTT5 is used today in production in mission critical use cases. So this is not a new thing which you can, we should wait, let's say, quite a few years until this is production ready and used today. And also make sure that if you have legacy devices out there, make sure that your vendor also provides a way to transition. Okay, so now I will answer some questions as the next steps. So what are the next steps if you're wondering? Reach out to me. Here's my email address. Reach out to me and schedule a conversation if you're curious about some of the things. If you want to have a chat about MQTT5, I'm more than happy to schedule a conversation with you. Otherwise, if you're interested in MQTT and Kafka, this is one of the next steps. So we have material here. So we have it on our website, on our blog, and we can also provide this to you in our newsletter. So make sure to subscribe our newsletter. Monitoring observability, cloud native MQTT and security. Huge topics. We will cover these very soon. So we have regular webinars rolling. And so please make sure to subscribe to the newsletter and also to our YouTube channel if you don't want to miss anything here. And yes, so that's it for me. I'm more than happy to answer any questions. I see there are some. There is now a feedback poll also open. So we would be very, very interested in how you're using MQTT today. This also helps us. And I would really appreciate if you do the quick survey, which should be open in your browsers right now. Okay, so thank you very much. And now we will do some Q&A. Okay. So. Okay, so then let's start for a question. What is the maximum message length for an MQTT broker? So the MQTT protocol says 256 megabytes. This is the maximum size. But this is usually not what you want to do in production. So most use cases we've seen are using less than 1 megabyte or less than 10 megabyte. If you're doing more, this could be an anti-pattern, but this needs to be discussed with with the technical people which are developing the solution. But in general, if you're using a broker, it supports up to 256 megabytes. If you require less, make sure to configure a lower limit, which most brokers like Mosquito and HiveMQ support. Okay. Then we have a question, why Amazon and Google do not support quality of service level 2. So I'm also a bit unhappy about this because this is a core feature of MQTT. I think you need to talk with them why they don't support this. In general, from an engineering perspective, it's pretty hard to do on a broker side at scale. This is where we as HiveMQ invested a lot of engineering time over the years. And so this is one of the harder features to implement if you're implementing a large scale MQTT solution. I'm not sure why they don't support this. I think best would be to talk to them and ask them if they can provide you this. Or if you are not a user of them, you can use a lot of other solutions which support this. Because most brokers support this really. And you can also run other brokers on AWS, on Google, on Azure. So if this doesn't suit your needs, then just use another product. Okay, then we have a question. Does the publish expire configurable per topic on connect or config, or am I enforced to add it on each push? So you can, so there are two ways to look at it. Of course, you can configure this on the broker. So as a default, this is what you can do. If you want the flexibility of the clients, you can indicate this on each publish message you're sending. So if you have a proper MQT library, this will take care. So you configure this once and then it will take care. But the MQ5 protocol really suggests to do this on every message. So you have the full flexibility. And there is no harm basically, because it's in the standard headers anyway. So there is not a lot of overhead you're creating. So I would make sure to send this on each publish. Okay, then we have a question. Is the shared subscription feature a competing feature or viable replacement for the Kafka Enterprise plugin? So very good question. So it really depends if you're using Kafka. So we have customers who don't use Kafka, who actually even replaced Kafka and using shared subscription as a lightweight communication layer. But there is, of course, if you, especially in large scale environments, if you need the Kafka features, then shared subscription not as powerful as Kafka. So this is just to bear in mind. And actually, a lot of use cases we have is where customers are using the Kafka extension and share subscription. It really depends. So from our point of view, it's complementary. If you don't require the complexity of a system like Kafka and it doesn't add a lot of value to your use case, I would suggest to try out share subscription first, if this fits your need or not. From a durability perspective, or from a message, let's say, durability perspective, it's basically almost the same. HiveMQ makes sure that no message is lost. If you're using Kafka, the same as share subscription, HiveMQ takes care of your messages. Okay, then this would be the last question for today. And the other questions, we will make sure that they also get answered. So we will share this afterwards. But let me quickly finish. With HiveMQ, does the shared subscription feature work even if the MQTT clients are using MQTT 3.1.1? Short answer is yes. HiveMQ supports shared subscription for MQTT 3. And you can use all the features, everything which you get with HiveMQ, with MQTT 5, also with MQTT 3. This is 100% compatible with HiveMQ 3. Okay, so there are still some questions open. Again, I and my team will answer these questions. So yeah, thank you so much.
Thank you very much, Dominic, for your very interesting webinar. We will upload the webinar on our YouTube channel. You will also get a follow-up email, which includes the link to our YouTube channel. You can also subscribe to our newsletter to stay updated on upcoming webinars. And like Dominic said, all unanswered questions will be answered on our HiveMQ community forum. So yeah, thanks everyone for participating. We hope you liked the webinar, and see you in November.